future might seem to decide the past. Not metaphorically, it can look that way. A choice you haven't made yet can appear to change what already happened. And that sounds impossible, because it is, until you look closer. Imagine you throw a ball. It leaves your hand, then it flies forward, then it lands. Simple. Cause, then effect. Always in that order. You flip a coin. It spins, then lands heads or tails. Again. First the action, then the result. Everything you know works like this. Cooking, driving, breathing, push first, result later. The past creates the future, never the other way around. That's the rule you trust, without thinking, without questioning. But what if this rule is not as solid as it seems? Now imagine a strange game, a beam of light, aimed at a wall with two holes, like two doorways. The light can go through both. In a very specific sense, we place a screen behind it to catch where the light lands. Here's what you'd expect. If light is like tiny bullets, it goes through one hole, then hits the screen. Two holes, two bright lines. Makes sense. But if light behaves like a wave, it spreads out. It passes through both holes and interferes with itself, like overlapping ripples. That creates stripes. Bright, dark, bright, an interference pattern. So here's the logic. If it behaves like a particle, we see two lines. If it behaves like a wave, we see many stripes. Clean, simple, predictable. Now we make it more interesting. We add a detector, a tiny device at the holes. It checks which path the light takes. Now we expect something obvious. If we measure the path, we destroy the interference. So the pattern should change. No more waves, just particle-like results. Two lines again. And it does. So far, nothing strange. But now, we delay the choice. We decide whether to measure after the light has already passed the holes. Now what should happen? The light already went through. Its past should be fixed. Your later choice shouldn't matter. Right? We run the experiment. Light passes the holes. No measurement yet. Then, at the very last moment, we choose what to measure. Path or interference. And something shocking appears. If we measure the path, we get particle-like results. Two lines. If we measure interference, we get stripes. But wait. The choice was made after the light passed. So what was it doing earlier? Did it take one path or behave like a wave? It seems the earlier behavior depends on the later measurement, as if the story adjusts to stay consistent, not changing the past, but refusing to define it early. That's the strange part. Let's slow this down, because this is where intuition fails. Think of it like a story, not fully written yet. Imagine a book with multiple possible plots. Before you read the ending, many versions are possible, different paths, different outcomes. Now you open the last page. Suddenly, only one storyline makes sense. The rest disappear. That's closer to quantum behavior. The light is not a tiny ball, not exactly a wave either. It's described by a wave function. Think of it as a map of all possible paths. Before measurement, multiple possibilities coexist, not in space, but in description. Then you measure. You ask a specific question. Which path? Or show interference, and the system responds accordingly. But here's the key idea. The experiment doesn't reveal a pre-written history. It selects one consistent outcome. There is no definite path before the measurement defines it. So it's not that the future changes the past. It's that the past was never fully decided. Now step back, way back. What does this mean about reality itself? We imagine time as a straight line. Past, present, future. Fixed and flowing forward. But quantum physics suggests something subtler. Events are connected by consistency rules, not just by sequence. Here's a thought experiment. Imagine solving a crossword puzzle. You fill in one word, then another. Sometimes, a later word forces you to change an earlier one, not because time reversed, but because the solution must be consistent. Now imagine the whole puzzle is solved at once. That's closer to quantum theory. The universe doesn't build step by step, like a simple chain. It settles into patterns that fit together as a whole. This isn't just philosophy, it shows up in real machines. Quantum computers use superposition. They process many possibilities at once. Then measurement selects a consistent answer. Quantum cryptography relies on measurement effects. If someone tries to observe, they disturb the system, and that disturbance is detectable. Even interference itself is used in precise measurements, from microscopes to gravitational wave detectors. So this strange behavior is not just strange, it's powerful. It shapes technologies we are only beginning to understand. Here's the uncomfortable question. When does reality become definite? At the interaction? At the measurement? Or when information becomes irreversible? No one agrees completely. And that's the honest truth. We can predict the results with incredible accuracy, but what it means is still debated. So you're left with this. A photon travels through space. It reaches a fork in the road. And until you ask a question, there is no single story. Not hidden, not decided, just open. And only when the question is asked does the universe give an answer that is consistent from start to finish. So the past feels solid, but maybe it becomes solid only when it has to.